Hello everyone, myself Kirtana H from Don Bosco Institute of Technology. Today I am here to present my project which I have done on Emertxe. The topic is car black box. So these are the contents which I will be covering in the further slides, that is C programming which I had learnt during this internship, and about the embedded systems, microcontroller, car black box, and I will be also showing the demo on our project. First is C programming. These are the things which I have learned during my internship. First is the introduction to C and data types, conditional constructs, operators and arrays, pointers and functions, recursion and strings, storage classes, and preprocessor. Next, coming to the introduction of C. C is a general purpose language. Even though it is applied and used effectively in various specific domain, it is also a free formatted language. Next, what I have learned is embedded system. The definition of embedded system is like that. It is an embedded system. An embedded system is a microprocessor-based computer hardware system with software that is designed to perform a dedicated function either as an independent system or as a part of large system. At the core, it is an integrated circuit which is designed to carry out computation for real-time operations. These are some of the examples of embedded systems. Embedded systems are categorized into 5 main types, like standalone, real-time, networked, and mobile. Coming to standalone, there we can see a slave system in which these systems are not intelligent even though they are embedded systems. These systems cannot take action by their own. Coming to independent system, these systems can take their action by their own. Next is real time. These systems are time-bound systems which will take out action on a specified time. Failures in these systems are not acceptable. Next is networked. These systems are connected to the network. Next is mobile. Here the systems which are movable are called as mobile system. So these are the components of embedded system. We can see actuators, DAC, memory, FPGA, sensors, ADC, etc. So coming to the requirements, the basic requirements of embedded system are reliability, cost effectiveness, low power consumption, efficient usage of processing power, efficient usage of memory. Next, the challenges which are faced are efficient input and outputs are required. Embedding an OS is also a challenge. Code optimization, testing, and debugging. Next, what I have learned is a microcontroller. Coming to the introduction of microcontroller, it is an integrated circuit which is capable of being programmed to perform a specified task. The design is normally restricted on its memory size, input-output capabilities, peripheral functions, etc. Next is the difference between microprocessor and microcontroller. Microprocessor contains all separate components and it is more flexible, and here the design is complex. Whereas in microcontroller, all the components are present on single chip. They are less flexible and the design is also less complex. These are the main things which we have to keep in mind while choosing a microcontroller. They are application, its performance, price, availability, and availability of tools, special capabilities. So in this, I would also be explaining about my project which I had done, that is car black box. First, I would like to tell you about what is car black box. Car black box is a device which is installed in the car, which will monitor few events and which will also be recording which will also be recording an event like accident. If an event accident if an accident happens, it will also record its speed and mileage, etc. Few car black box will also record locations also. It is also called as event data recorder. These are the requirements for creating a project, that is MPLabX IDE, which is a development environment, and MPLab XC8 compiler, and PixSimLab simulator for simulating. So this is a block diagram of PIC16F877A. PIC16's F877A is a Picgenius board from Microchip. We have used this microcontroller in our internship. It is of size 8-bit and it contains 5 ports, namely port A, which is of 6-bit and it is an analog pin, and port B, which is of 8-bit and it is a bidirectional port, port C, which is of 8-bit. Here the pins are digital, which are used for serial communication, and port D, that is also of 8-bit. Here all the pins are digital, and the last is port E, which is 3-bit. Next component is LED. LED is an external device connected to the microcontroller port. Port is an interface between the controller and external peripheral. We have seen that there are totally 5 ports. So from the schematic, we'll come to know that LEDs are connected to port B and port T. From the section of port B, it is clear that there is one more register associated with it, named TRISB. The TRISB register is very important for I/O configuration. The value put in this register decides the pin direction. So coming to tackle keys. Tackle switch is a switch whose operation is perceptible by touch. Here we can see in the diagram, it contains a metal plate and a terminal. So this switch used to select the mode of operation and to enter the temperature and to enter the time in our project. The switch will produce a bouncing effect when a switch is pressed. As we can see in the diagram, when the switch is pressed, we can see a contact bounce period, and also when we release the switch, we can see a contact bounce period. That is because when we press or release the button, we can see this metal plate comes in contact with the terminal. Next is matrix keypad. This is a keypad in which number of tactile switches are connected in row and column concept. These keypads are most commonly used in telephones, calculators, digital lockers, etc. Next is interrupt service routine. An interrupt is a communication process which is set up in a microcontroller in which the external or internal devices request the microcontroller to stop the processing. Then the microcontroller acknowledges the request and attends to the request. It goes back the processing where it got interrupted. An ISR is a software routine that hardware invokes in response to an interrupt. Interrupt service routine attends to the request of an interrupting source by clearing the interrupt flag and should save register contents that may be affected by the code in the ISR. Next is timers. Timer is an important application in any embedded system. Like it is a default peripheral which maintains the timing of an operation in sync with a system clock or an external clock. Register width of the timer is called resolution. It can be of 8 or 16-bit. It has many applications such as measuring time and generating delays. Tick is, here we can see 3 different things. That is tick, which is referred to as the change in number, change from one number to another number. It can be either up count or down count. Next is quantum, which depends on the system clock setting. It is a measure of time which is responsible for the tick. Scaling may be pre-scalar or post-scalar. It may be 1:1, 1:8, or so on. Next is CLCD. The full form of CLCD is Character Liquid Crystal Display. This is used to display the ASCII character and some special characters. In PiximLab, there are two types of display. One is 16x2 display and the other is 16x4 display. Here, most commonly used one is 16x2. There are two types of communication modes in CLCD. One is 4-bit mode and the other is 8-bit mode. Next, coming to the project demo. Here I'll be introducing like what is black box and why is it required, features of black box, requirements, and I've already done my project, so I've put some screenshots of it. And next is I'll be also implementing the project. Introduction. So like what is black box? Black box is something which is either physically installed in the car or it is downloaded as a smartphone app which links to a GPS device and measures and records vehicle speed, location, distance traveled, driving frequency, and time of day the car is in motion. Next, the features of black box are it gives an exposure to a 110 degree centigrade for an hour and 260 degree centigrade for 10 hours. And it can operate between minus 55 degrees Celsius to plus 70 degrees Celsius, and it can carry a minimum 24 hours of flight data. Then it is also submerged under the equivalent of 600 meter of seawater for 1 month. So for doing the project, the main requirements are we should be knowing embedded C, and next is MPLab IDE, Xe8 compiler, and PiximLab. In PiximLab, we'll be displaying all these default screen, login screen, main menu, view log, set time, and event capture. So these are the outputs. I've already done my project. First, in the first picture, we can see that it is a default screen which displays the current time, the latest event, and the current speed. Next, in the second figure, it is user login. It is asking for the user to enter the password to browse through the available menu. Next is the main menu. When the user enters correct password, he'll be allowed to browse through the main menu, available menu. In main menu, we can see two options. One is view log and clear log. And next is the lock screen. In lock screen, we can check the status of engine. Coming to the simulation part, we can see all the X files which are present in the header files, and the source files are present in the source file directories. And here we can see the initialization is done. Next, we'll load the hex file in PiximLab. Firstly, we can see the default screen which displays the time, event, and the speed of the car. The speed of the car can be varied using these switches, potentiometer. The speed of the car varies from 0 to 99. Next, we can change the event. Firstly, the event it is showing that the car is in the on state, and we can change the gear by pressing the tactile switches, that is RB1. GN is the neutral gear. see it is showing that the collision has happened. Main menu, firstly we have to enter the password. While if the user enters a wrong password, he'll get a total 3 attempts. If he firstly have typed the wrong password, so I have left 2 more attempts. It displays as wrong password and I have been left with 2 more attempts. To visit the main menu, I'll enter the password now. Here I have entered a wrong password. Totally the user gets 3 attempts. First attempt is already gone and I have been left with 2 more attempts. After few seconds, it again prompts to enter the password. Now it is again asking to enter the password. Now also I have entered a wrong password. It is showing wrong password and only 1 more attempt left. Next, it is again asking to enter the password. I have entered the password wrong thrice, so I have been blocked and I should wait for 60 seconds to unlock it. Uh, let's see what happens when the password entered is correct. Now I'll enter the password. After entering the correct password, we can see the main menu. Here we can see view log and clear log. When view log, clear logs are selected, all the logs which were used before are cleared successfully. Next, after clearing the log successfully, for changing password, we have an option in main menu. In main menu, we can see 2 options, that is view log and clear log. By pressing either RB3 or RB4, we'll select the view log option. Under view log, we'll get further 2 more options, that is clear log and change password. Here, by pressing Here by pressing on RB3, we'll choose the change password option. Now it is prompting us to enter the new password which we wanted, which you would like to change. After entering it once, it asks us to enter the password again. On successful entering the password is changed successfully.